Hello, friends. How y'all doing today? All righty, we're gonna head on back here. We're gonna do a little bit more work um, in trigonometry, but we're gonna start the next section here. And this next part is what we call analyzing trig or analytical trigonometry. Now, this tends to fall under a lot of formulas. So if you there'll be a formula sheet on your guys' Schoology page for you guys to access. Um, but a lot of this is going to be proofs and solving equations and looking at various relationships. So this one is really going to kind of make you think. I think it's a lot of fun, but it does make you think a little bit, and it takes a little bit of getting used to. So we're going to look at some what we call our Pythagorean identities. Now, our Pythagorean identities. Let's take a look at the unit circle again here. So remember on the unit circle, it's based off this idea that we have a radius of 1. And I'm not going to draw the circle all the way around because we just really need to look at one point here. And every point on that unit circle is some x and y. Now, we said this point, x is the same thing as cosine, and y is the same thing as sine on the unit circle. So if we were to drop a perpendicular line all the way back down to the x-axis, we'd have our theta here, and we'd say that this is x and this is y. Well, this is a right angle, so a right triangle. And friends, the most proven theorem in mathematics is the Pythagorean theorem. And what that one says is that x squared plus y squared equals z squared or r squared. And a lot of you guys learned it as a squared plus b squared equals c squared. But again, I'm not telling you guys anything new or anything you don't know. So we have x squared plus y squared equals 1. Now, if we take this to trig, we said that x is the same thing as cosine theta. And y is the same thing as sine theta. And so when we substitute cosine and sine in for x and y, we get something, our basic, what we call our basic Pythagorean triple or Pythagorean identity. And what that says is that the cosine squared of theta plus the sine squared of theta equals 1. Now that's not the only Pythagorean identity that we have. I'm going to show you where the other ones come from. So cosine squared theta plus sine squared theta equals 1. And I'm going to write that a second time because there's 2 more identities, and we kind of want to just take a little look to make sure we know exactly where they come from. Now, if I take this first one and I divide everything by cosine squared, we see some cool things here. So we divide everything by cosine squared, whoop, and we get cosine squared divided by cosine squared, we end up with 1. Sine squared divided by cosine squared, and we get sine divided by cosine, sine over cosine, well, that's tangent. And 1 over cosine, well, that would be secant. So we get another Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. And if we do the same thing but divide by sine squared, we end up getting cotangent squared plus 1 equals cosecant squared. And these three right here, these are called our Pythagorean identities. Now we're going to add these to the things we already know. We already know the reciprocals. We already know the that tan is sine over cosine and cotangent is cosine over sine. Now knowing these plus reciprocal relationships, we're going to be able to actually go through and prove some various identities. We also know, already covered odd and even, and we covered complementary, but we'll get to those and deal with those tomorrow. Today we're just going to be dealing with these Pythagorean identities and then our reciprocal relationships and then tan and cotangent. So what are we going to do with these? Well, here's these identities that we have right here. And again, the ones that aren't listed here, we still have as well. Don't forget, we have things like 1 over sine is cosecant. And cosecant is also, 1 over cosecant is also sine. So these are what I mean by the reciprocal identities. And you can do the same thing with secant and cosine, as well as tangent and cotangent. And we did that already back when we first started trig a bit ago. So what we're going to do is we're going to be proving some different trig identities. Now, we got a bunch of little things here. As we go through, we're working on proving these identities. One of the big things you need to ask yourself, especially when we're doing the proofs and not in verifying an identity, is you always want to look and say, well, what side to me looks like the uglier side? What side just looks like a big giant mess? And whatever side that is, that's the side we're going to play with and try to make it look like the other side. Now we only get to play with one side. You can only manipulate one side. And we're going to use our trig identities in algebra to make it turn into one side. Now, one other little bit that also is going to come up into play here, and you'll see this as we go through this next little bit, whenever you get in trouble, and you can add this to your notes, go ahead and turn everything into sine and cosine. Now, that is not a do that every single time. Sometimes you don't want to, but if you get just like stuck and you're in a jam and you can't go anything, sometimes it helps just to look at it in a different way. And one of the ways to do that is every trig function we can turn into sine and cosine. So sometimes it helps just to get everything in terms of sine and cosine. So we're going to go through it and we're going to be doing what we call some trig identities. So let me show you what these kind of look like here. First up, we're going to simplify some expressions. Now, when we simplify these expressions, realize we're going to go as far as we can on them until we can't go any further. Okay, so let's take this 1 minus cosine theta, and we're going to multiply it by 1 plus cosine theta. And so we're either looking for one of our trig identities, one of our trig relationships, a Pythagorean triple, or the Pythagorean identities, or one of our reciprocal identities, or we're doing algebra 1. Now, friends, if I'm looking at something like this, I'm going to multiply it out. So again, if you're a person that still uses the box to multiply that we learned about an area model, that's fine. All right. I'm not going to tell you not to do that. Nothing wrong with that. And you can use a little generic rectangle to help you to multiply it out. Otherwise, just FOIL it. So multiply your two binomials together and FOIL it and get it to and figure out what you end up with. So I'm hoping you guys still recognize that this is a difference of squares, but if you don't worry about it. I'm going to multiply it all the way out just so we can see it. Even though we're saying use our algebra, sometimes we just kind of forget some of our basic algebra rules, and that's okay. So we're going to just keep going until we can't go any further. So I end up with 1 minus cosine squared theta. Now it looks like I can't do any more algebra. So if I can't do any more algebra, then I look at it and say, all right, well, is there something that I might be able to do that I could possibly be able to do that would be something to do with trig? And so the only trig thing I see here is cosine squared. So I think to myself, when does cosine squared pop up? Well, that's one of our trig identities, one of our Pythagorean identities. We had cosine squared plus sine squared plus sine squared equals 1. So this 1 minus cosine squared, that's the same thing as cosine squared plus sine squared equals 1. So I look at it and say, well, is there a way that I can either make this whole expression come up or maybe do a substitution? And I'm looking at this thing and I'm thinking to myself, what if I were to get sine squared by itself? So if I move the cosine to the other side, I get 1 minus cosine squared theta. And then when we're looking at it, 1 minus cosine squared theta, 1 minus cosine squared theta. Well, 1 minus cosine squared theta, that's the same thing as sine squared. So I can clean it up a little bit more. I go down from 2 terms down to 1 term. Well, this is about as simple as I can make it because I only got 1 term. If I can get some down to 1 term, that's a great day. We're all done. So go ahead and pause the video here and see what you guys can do with this one. Is there any way you can turn this one into something else, into simple terms? Go ahead and pause the video and see what you do. All right, friends, let's take a look here. So 1 over sine squared theta minus 1 over tan squared theta. So I see these fractions 1 over something. That makes me think of reciprocal. So what's the reciprocal of sine? So 1 over sine, that would become cosecant squared theta. I have a reciprocal. And I do another reciprocal. 1 over tangent squared theta. What does that become? Well, that to me is cotangent squared. So I make it simpler just by taking it out of the denominator. Now I'm looking at it thinking, all right, is there some other type of relationship that I know that deals with cosecant and cotangent? And in this case, yeah, we got one. 1 plus cotangent squared theta equals cosecant squared theta. Well, if I were to play with this identity, move the cotangent to the other side, I get cosecant squared theta minus cotangent squared theta is equal to 1. So now if we take a look at it here, cosecant squared theta minus cotangent squared theta, cosecant squared theta minus cotangent squared theta, I can make this even simpler. Turns out this whole thing right here is equal to 1. And I'll be honest, they're not a whole lot simpler than 1. That's about as simple as it gets. So on these simplifying ones, all we're trying to do on these is just go as far as we can until we can't go any further. So why don't you guys go ahead and pause and try this next one. So pause the video, see if you can't see how far you can take this before you can't go any further. All right, go for it. All right. So the first thing I do is I'd go ahead and bring this whole thing out because I'm going to multiply it all the way out. And again, I'm not going to use your generic rectangles. I'm just going to FOIL it out fairly quickly. So I have a perfect square trinomial going on here. I'm going to multiply this entire thing. So when I multiply it, sine squared, again, all we ever do is our algebra rules, or we look for some trig identity. Plus 2 sine x cosine x. That 2 sine x cosine x, that's something we're going to get to here in about a week later. There is something special going on with that. We're just not going to call it special right now. Plus cosine squared x. Well, I see the sine squared and the cosine squared, and I'll be honest, I kind of like to put those together. I like to, whenever possible, take my squares and put them together. So now when I'm looking at this here, friends, I'm asking myself, is there a way that I can make this somehow cleaner? And if you remember back up here, we said that cosine squared x plus sine squared x equals 1. So cosine squared x plus sine squared x, turns out that's just a big giant 1 right there, friends. So I can clean this up a little bit more by turning that into 1. So 1 plus 2 sine x cosine x. Now, 2 sine x cosine x, there is nothing I can do with that, so that is going to have to be left alone. We'll just have to leave it be, at least for the time being. There's going to come a time when I do a little bit more. So we're just simplifying these expressions as much as possible. And that gets us to the thing that we really want to kind of play with. The thing we're going to spend a majority of our time here, called proving and verifying trig relationships. Now, this is where we were talking about. You're going to pick one side. You only get to play with one side. So you're going to pick one side and do everything you can to it. And when you can't do anything else, call it a day. And how do we know when we call it a day? When it looks like the other side. So I'm going to look at both of these things. I'm going to pick the side that I think is ugly, and I'm going to do everything I can to it until I make it look like the other side, and then I call it and say, all right, now the two sides are equal. I'm good. But the key here is I can only play with one side. So if you're looking at this, what looks to be a little bit worse? Well, friends, in my mind, I'm looking at the left and I see two trig things on the top. I see a fraction. I see Pythagorean stuff on the bottom. On the right side, I just got one trig function. So in my mind, the harder side is the left side. So that's going to be the thing I play with. And so it doesn't really matter what I do. I just can do one thing after another. All right, just do one thing at a time. So a lot of times I look at it and say, well, if I have a Pythagorean, I usually will try to start with that. So I look at it and say, all right, well, cosine. What dealt with cosine? That was sine squared x plus cosine squared x. That's where my cosine squared showed up. So if I want to get sine squared by itself, I'm going to move the cosine squared x to the other side. And then, friends, at that point in time, I'm looking at it right here, and I'm thinking, all right, here's my 1 minus cosine squared x. Here's my 1 minus cosine squared x. So on that left-hand side, in place of that 1 minus cosine squared x, I can make it equal to sine squared x. And again, we're just trying to get rid of one thing after another. One thing after another. So change that to sine squared x right there. And we're going to keep working on this left-hand side until we make it turn into the right-hand side. So I'm still trying to make this turn into cotangent x. Now notice, I'm bringing that cotangent x down with me the entire way. So I'm always just looking, do I have any trig identities or do I have any algebra? In this case, now I'm looking and going, I think I have some algebra. I got a sine x on top, I got a sine squared x on the bottom. I can get rid of one of these sine x's by canceling them out. And that leaves me with cosine x over sine x. And that would be equal to cotangent x. And now I have one final little trig identity here. Cosine over sine, that is cotangent. Sine over cosine is tangent, but cosine over sine is cotangent. And so now I've made that left side turn into the right side. Now, as math people, one of the things we like to do is we like to kind of just cap it all off and just say, hey, we're done. So a lot of times you'll see some people, they'll put a little box here after it's saying I'm done. Sometimes you'll get people that get really, really fancy. And they'll type this little abbreviation, Q, E, D. All right, and I'm pretty sure we don't have any Latin people here. I mean, maybe some of you guys came from John Adams and you guys learned a little Latin over there, but QED is quad. Oh, my Latin's not good. Ered demonstrad. Oh, I can't even say it. Destroydum. I think I spelled that right. Again, my Latin, it's been a while. Basically what that means there is this, which was to be demonstrated. So you'll see different people that'll say different things here along the way. I did spell that wrong. S-P-R-A-R. There we are. So QED, or you can put a little box at the end. Either way, we just want to do something that says, hey, we know we're at the end. I mean, the reality is when you get the left side to match up to the right side, yeah, of course you're at the end. But we want to do something mathematical just to say, yeah, we're done. So you either use a little box or you use QED, doesn't matter. You'll see both in various textbooks that you guys will come across or different proofs that you'll come across later on. So that just gives you an idea what those are basically saying. Okay. So what we're going to do is we're going to try a few of these here, and we're going to call it a day. So I'd like for you guys to try this one. Now, it's a little bit harder. Notice the left side is harder than the right side, but I got 3 different trig functions. So when it's really ugly, when in doubt, turn everything into sine and cosine. So that'll be my hint for you. I want you guys to try number 5 here. Start by turning everything into sine and cosine. See what that does for you. All right, take it away. All right, so sine and cosine. So here we go. So first of all, I got to write it here. Cosecant minus cotangent secant theta plus 1 equals tangent theta. Now, I'm hoping you guys all would have recognized that the left is the uglier side, so that's the side I'm going to play with. And I'm going to turn everything into sine and cosine. I see 3 different trig functions out there. I don't want to be dealing with 3. So I know I can cut it down to 2 pretty quickly. So 1 minus sine theta. Cotangent is cosine over sine. And then secant is 1 over cosine. And then I have a plus 1. So I'm going to take each of these here, and I'm just going to do a little algebra. I'm going to take each of these and write them as a single fraction. So 1 minus cosine theta over sine theta. So I got my left term over 1 fraction. Now I'm going to do the same thing with my right term. Now, realize 1 is the same thing as cosine over cosine. So when I turn this other one into it, I can end up with 1 plus cosine theta, because cosine, or 1 is cosine over cosine. 1 is anything over itself over cosine theta. So I write it as 1. And again, if you're having a little trouble seeing that, let me see if I can't split that up a little bit more for you. 1 over cosine theta plus 1. I can put that over 1 and multiply top and bottom by cosine theta over cosine theta. And that's where I end up with my 1 over cosine theta plus cosine theta over cosine theta. All right, so let's keep going here. I'm going to multiply these two terms straight across. So 1 minus cosine theta, 1 plus cosine theta. That's the difference of squares. So I have 1 minus cosine squared theta all over sine theta times cosine theta. So we just keep going, keep plugging away, trying something, looking for something until we get to one side to look like the other side. Well, now I see a squared, 1 minus cosine squared. So again, I ask myself, when does that pop up? Well, sine squared theta plus cosine squared theta equals 1. So that means sine squared theta equals 1 minus cosine squared theta. Now, if you see this, you don't have to do this little Pythagorean identity stuff off to the side. If you see this, you can just go ahead and make that substitution. Totally good with that. So sine squared theta will go in place of the 1 minus cosine squared theta. And we're just about at the end here. And friends, I know that this is going to take a little time. So this is not like a one and done thing. We're going to spend a few days here just kind of playing around with this a little bit, playing around with verifying identities, because it does take a little bit of time. All right. And it's going to be one of those things where eventually a light bulb is going to switch on. You're going to say, oh, I get it. Again, we're always looking either to do algebra or to do a trig substitution. For algebra, you're looking to multiply two binomials. You're looking to factor, which we haven't got to yet. You look to have rationalize, get everything over the same denominator. So you're just using your algebra skills, but you're using trig functions with your algebra skills. So tangent theta equals tangent theta. We have reached the end of this one. That one is golden. All right, friends, you see the next one there. Why don't you go ahead and give that a shot? So go ahead and pause the video and see how you do with that. And we'll take a little gander at it here in a second. All right, let's see how y'all did. So I'm looking at this thing right now. I see cosine theta over 1 plus sine theta. Plus 1 plus sine theta over cosine theta. Equals 2 secant theta. Now, I don't know about you, but in my mind, the uglier side is definitely the left side. So that's going to be the side that I'm going to play with here. Well, friends, I have two fractions here. I can't do much with them until they have the same denominator. So I'll tell you what I'm going to do. I'm going to multiply them, make them have the same denominator. So back in integrated one, we call these fraction busters. So we're going to make them have the same denominator. So multiplying one trig function by the other trig function, that's just 1. And there's a lot of ways I can multiply by 1. So this one is going to be 1 plus sine theta over 1 plus sine theta. So we're going to make everything have the same denominator. So when I go to put all these together here, this one right here, I have to multiply those two binomials together. So I end up with cosine theta times cosine theta. That'd be cosine squared theta. 1 plus sine theta times 1 plus sine theta. That's 1 plus 2 sine theta plus sine squared theta. And everything is going to be over cosine theta times 1 plus sine theta. I see a couple little squared terms. So I got a cosine squared and I got a sine squared. And the great thing about cosine squared and sine squared, this is one of those bells and whistle type things there, friends. We know that if we were to put them together, sine squared plus cosine squared, we would get that equal to 1. It's another one of our Pythagorean identities. So if I were to take cosine squared and I were to add sine squared to it, together those would become 1. So 1, and I still have that plus 1, 2 sine theta. You can see how we're just kind of slowly but surely just kind of whittling things down here until we get things to be a little bit more useful. Also notice, I didn't multiply this cosine into this parenthesis because I don't know what I'm doing with it yet. I don't like to multiply until I know that I absolutely have to. So I'll do the basic algebra that I have to do if I can't do anything else or if I get stuck along the way. So 1 plus 1 is 2. I can combine that pretty darn quick. That gets back to kindergarten. So now I see my numerator. I have 2 terms that both have 2 in it. So since I have 2 terms that have 2 in it, I'm going to go ahead and factor that 2 out. And get it down to 1, 2. I know that I want 1, 2 because over on the other side I see a 2, a single 2. So I can get it down to a single 2. I know I'm doing pretty good. And I have cosine theta over 1 plus sine theta. And if you notice, your friends, other than the cosine squared theta plus sine squared theta, I haven't done any trig here. This has all been just algebra 1. Got a common denominator, so I can cancel it out there, or a common factor, I should say. Everything I'm doing here is just algebra. I just happen to be using trig with my algebra. I don't know why I added a square to the other side. I just realized that. So that's 2 secant theta. And if I want to get cosine out of the denominator, I just do a reciprocal on it and make it 2 cosecant, 2 secant theta. So very little trig I did there. I had 1 Pythagorean identity and I had 1 reciprocal. The rest of it is just algebra 1. All right, friends, last one for the day here. See if you guys can't take a little try on number 7 there and see what you can come up with. All right, I'll come back and talk to you in a sec. All right, here we go. So if I'm looking at the sine to the 4th x minus cosine to the 4th x, I have sine squared x. Whoop. So now I notice on the bottom that I have the difference of squares, or I have 2 perfect squares. And it is a difference of squares. I could factor the bottom. However, up at the top, I have sine to the 4th and cosine to the 4th. Well, that's a bigger difference of squares. So I'm going to do my difference of squares on my numerator. I'm not going to worry about the denominator yet. Again, I only do what I have to do. And then if I can't do anything with it, then I'll do more algebra to see what I can come up with. So I'm hoping you guys factored this when you pause the video. Or let's not kid ourselves. Some of you guys, you just kept rolling. You knew I was going to get there. All over sine squared x cosine. squared x. Well, I see some common terms there, so that means common terms. We can factor them out. I'm left with sine squared x plus cosine squared x. You guys can already see that that is going to be the actual Pythagorean identity, but we can't stop here. Some of you guys will have the tendency to want to say, oh, well, yeah, that's true. That's one of our little identities, and you're going to leave it alone. You still have to make that final trig substitution. So you can't just leave it like that. You got to make the trig substitution of sine squared x plus cosine squared x equals 1. So in place of sine squared x plus cosine squared x, we're going to put 1, and then it equals 1. And we are done. All right, friends. I know these take a little bit of time, so we'll see you in class tomorrow morning, and we'll talk more about this. And we're just going to kind of play around proving these trig identities for a few days here, just to really make sure we really got a great handle. So I'll see you in the morning. Have a great rest of the evening, and talk to you guys later.